Welcome to my channel. Let's solve some exercises on arithmetic sequence and series. For this, we'll use the known formulas for the nth term and the sum of terms of an arithmetic sequence. Let's have the first item. Find the 100th term of the sequence 2, 4, 6, and so on. Here, we'll just use the formula for the nth term, which is given by a sub n equals a sub 1 plus n minus 1 times d, where a sub n is the last term, or the term that we are finding, a sub 1 first term, and the number of terms, d the common difference. Let's list down the needed values. A sub 1 obviously is equal to 2, n is equal to 100 since there are 100 terms from the first term up to 100th term, and the common difference is just equal to 2. So just subtract the first term from the second term, or subtract the second term from the third term. Let's plug in these values to find a sub 100. So a sub 100 equals 2 plus 100 minus 1 times the common difference 2. So we have 2 plus 99 times 2. So we have 2 plus 198, which is equal to 200. So the 100th term for this sequence is 200. Item number 2. Find the 70th term of the sequence 2 square root of 5, 4 square root of 5, 6 square root of 5, and so on. This is not really different from the first item since this one also uses the formula for the nth term, only that the terms now use or involve radical numbers. So again, a sub n equals a sub 1 plus n minus 1 times the common difference d. A sub 1 is equal to 2 square root of 5. The number of terms is 70. The common difference is equal to the difference between the first term and the second term. So we have 4 square root of 5. We write first the second term and then we subtract the first term, which is 2 square root of 5. So the common difference is 2 square root of 5. Plugging in the values, we have a sub 70 equals 2 square root of 5 plus 70 minus 1 times the common difference 2 square root of 5. Then we have 2 square root of 5 plus 69 times 2 square root of 5. Let's multiply first 69 and 2. So 69 times 2 must be equal to 138. So this is 138 square root of 5. So the 70th term is 140 square root of 5. Item number 3. Find the first term and the common difference of an arithmetic sequence whose 8th term is 8 and whose 20th term is 44. Alright, so how do we answer this problem? Let us relate a sub 1, or the first term, to each of the 8th term and the 20th term. Take note that a sub 1 up to a sub 8, there are 8 terms. So we can say that a sub 8 is equal to a sub 1 plus 8 minus 1 times the common difference d. We know that a sub 8 is 8, so 8 equals a sub 1 plus 7d. Now we have a linear equation in two variables. So if we have another one, we can easily solve for a sub 1 and d. So let us relate also the 20th term to the first term, a sub 1. Similarly, from a sub 1 to a sub 20, there are 20 terms. So a sub 20 is equal to a sub 1 plus 20 minus 1 times the common difference d. A sub 20 is 44, so 44 is equal to a sub 1 plus 19d. So now we have another equation in two variables. Now we can easily solve for a sub 1 and d. Obviously, we can just eliminate a sub 1 and solve for d first, right? So we can do that by multiplying both sides of this first equation by negative 1. Alright, so we have negative 1 times a sub 1 plus 7d. So we have an equivalent equation which is negative 8 equals negative a sub 1 minus 7d. Alright, so let us use this instead. So I'm going to write the equations here. So we have 44 equals a sub 1 plus 19d. And then this one, negative 8 equals negative a sub 1 minus 7d. Now adding, the left side is 36. The right hand side, of course, this one cancels. So we have 12d. And so if we divide both sides by 12, we get d equals 3. So the common difference is 3. Now to solve for a sub 1, we choose either the first or the second equation, but the first equation is obviously the easier one to handle because the numbers are smaller. Let's use that one. Let us sub in d equals 3. So from here, we have 8 equals a sub 1 plus 7 times 3, the common difference. So we have 8 equals a sub 1 plus 21. Putting together or placing 21 in the left hand side, this has to be 8 minus 21 equals a sub 1. So a sub 1 is negative 13. Alright, so this is the first term. Item number 4. Find x so that x plus 3, 2x plus 1, and 5x plus 2 are consecutive terms of an arithmetic sequence. Let us write first the given expressions. So we have x plus 3, 2x plus 1, 5x plus 2. So this is our first term, a sub 1. This one, second term, a sub 2. Third term, a sub 3. Now, since this has to be an arithmetic sequence, it is true that a sub 2 minus a sub 1 is equal to a sub 3 minus a sub 2, since it has a common difference. Now, using this template, we can have 2x plus 1 minus x plus 3 equals 5x plus 2 minus 2x plus 1. Distributing the negative 1, we have 2x plus 1 minus x minus 3 equals 5x plus 2 minus 2x minus 1. Combining like terms in each side, we must have x minus 2 equals 3x plus 1. Now I'm going to rearrange this one so that all terms with x are in one side and all constants are in another side. So this has to be x minus 3x equals 1 plus 2. Alright, so we have negative 2x equals 3, which means that x equals negative 3 halves. Alright, so this is the value of x. Now how can we check whether our answer is correct? We can plug in negative 3 halves here and see if the resulting numbers will have a common difference. Okay? Item number 5. Find the sum 1 plus 3 plus 5 up to 59. Since this is already an arithmetic series, we'll use the formula S sub n equals n over 2 times 2a sub 1 plus n minus 1 times the common difference d. However, we don't know yet the number of terms, but we know that a sub 1 equals 1. Common difference is obviously equal to 2. And we still have to find the value of n, or the number of terms. Now, to find the number of terms, we can use here the formula for the nth term. Take note that a sub n equals a sub 1 plus n minus 1 times d. We can substitute here the first term, the last term, which is 59. So this is a sub n, the common difference of 2, and then solve for n. So let's do that. So the a sub n here is 59. A sub 1 is 1. So that's 1 plus n minus 1, common difference of 2. So we have 59 equals 1 plus 2n minus 2. So we have 59 equals negative 1 plus 2n. So we have 59 plus 1 equals 2n. So 60 must be equal to 2n. Dividing both sides by 2, we have n equals 30. Now we can solve for the sum. So from the first term 1 up to the last term 59, there are 30 terms. So the sum of these 30 terms, s sub 30, is equal to 30 over 2 times 2 times a sub 1, which is 1, plus 30 minus 1 times the common difference of 2. Simplifying, this is 15 times 2 plus 29 times 2. Simplifying the inner operation, we must have 2 plus 29 times 2 is equal to 58. So this is 15 times 60. So the final answer here is 15 times 60, which is 900. Item number 6. Find the sum negative 9 minus 5 minus 1 plus a bunch of positive numbers up to 39. Alright, so this one is not really different from the previous one, only that in this series, 3 of the terms are negative. So what will we do now? Take note that the series is the same as negative 9 plus negative 5 plus negative 1 plus a bunch of positive numbers up to 39. Now let's list down first the needed values. A sub 1 obviously is negative 9. The common difference can be found by subtracting a sub 1 from a sub 2, the first term from the second term. So that's negative 5 minus negative 9. So the common difference is negative 5 plus 9, which is equal to 4. However, we don't know the number of terms, n. So what we're going to do now is use first the formula for the nth term to find the number of terms. So we can treat this one as a sub n. So in the formula, a sub n equals a sub 1 plus n minus 1 times d. A sub n is 39. A sub 1 negative 9 plus n minus 1 times the common difference of 4. Alright, so let's distribute 4. We have 39 equals negative 9 plus 4n minus 4. Then 39 is equal to negative 13 plus 4n. Placing negative 13 in the left side, we have 39 plus 13 equals 4n. So the left side is equal to 52. So we have 4n equals 52. Dividing both sides by 4, n is equal to 13. So now we can solve for the sum of all the terms, which is s sub 13. Take note again, s sub n is n over 2 times 2a sub 1 plus n minus 1 times d. So s sub 13 equals 13 over 2 times 2 times negative 9 plus 13 minus 1 times the common difference of 4. So we have s sub 13 equals 13 over 2 times negative 18 plus 12 times 4. So we have 13 over 2 times negative 18 plus 48, which is equal to 13 over 2 times 30. And take note, we can just divide first 30 by 2 so that we will get 13 times 13 times 15. And so s sub 13, or the sum of the 13 terms, is 195.